Hey everyone, all around us right now, there's this ancient, totally natural process going on. It's an invisible chain reaction that starts deep inside the Earth. So today, we're going to pull back the curtain and see exactly why this invisible process matters so much to you. So, to kick things off, I've got a question for you. Think about an invisible, completely natural gas, something you can't see, you can't smell, you can't taste it, but it's also a leading cause of lung cancer. Any ideas what that might be? The answer is radon. And what's kind of wild is that it's a noble gas. That just means it's chemically, well, lazy. It doesn't like to react with other things. And that stability is exactly what lets it travel so easily right from the ground up into the air we breathe. And, well, that's where all the trouble really starts. Okay, let's get into this. How on earth does something that forms way down in the Earth's crust end up inside our houses? I mean, it's a surprisingly simple journey from the soil right into the places we think are safest. So it all starts with uranium, which is an element you can find in pretty much all rock and soil. As that uranium breaks down over time, it decays. One of the things it creates is radon. Now, because radon is a gas, it can move really easily up through the ground and right into our homes through tiny cracks in the foundation we'd never even see. Once it's inside, especially in places without much airflow like a basement, it can just build up and up to dangerous levels. But to really get a handle on radon, you kind of have to look at its family tree. See, it doesn't just pop out of nowhere. No, it's part of this really, really long line of atomic changes that actually started billions of years ago. And that process has a name. It's called a decay series. The best way to think about it is like a huge set of atomic dominoes. You have one big, unstable atom that starts the whole thing by falling apart, and when it does, it knocks over the next one in line, which then becomes unstable and falls, creating this whole cascade of different elements, these so-called daughter isotopes, all the way down the line. So the family we're talking about here starts with the big one, the great-great-grandparent of them all, uranium-238. It takes about 4.5 billion years for half of it to decay into its first daughter, thorium-234. That process keeps going through a bunch of steps and eventually creates radium-226, which is a solid. And then that radium decays into our main character, radon-222, the gas. And here's the thing you really need to get. This isn't some rare thing happening in a couple of weird places. The source material, uranium-238, is a basic building block of our planet's geology. It is literally everywhere. And that means the potential for radon to be produced is also, well, everywhere. So when we say an atom decays, what is it actually shooting out? What's the thing that makes this whole process dangerous? The answer is a tiny but unbelievably powerful little projectile. It's called an alpha particle. And really, it's just the core of a helium atom, but it gets launched out of that decaying atom at an incredible speed. It is just packed with energy, but, and this is key, it can't travel very far. It can be stopped by something as thin as a piece of paper or even the top layer of your skin. And that leads to this really fascinating paradox. Think about that for a second. Harmless outside, deadly inside. The exact same particle can be either totally harmless or incredibly dangerous. The only thing that changes is where it is in relation to your living cells. Okay, so let's break this down because this is everything. Outside your body, an alpha particle just bounces right off the layer of dead cells on your skin. It's stopped cold, no big deal. But if the atom that's shooting out that particle is inside your lungs, well, there's no protective layer in there. That high-energy particle gets fired at point-blank range, like a tiny cannonball, straight into living tissue. And that kind of energy is what we call ionizing radiation. When that little alpha particle cannonball smashes into a molecule, it's powerful enough to literally knock electrons right out of their orbits. And if the molecule it happens to hit is a strand of your DNA, that physical damage can actually break the strand or mess up its code. And that's what we call a mutation. So let's put all the pieces together now. Let's follow the entire path, from the air in a room all the way down to a potential mutation happening deep inside one single cell in your lungs. It starts with something you don't even think about, just taking a breath. If you happen to be in a room with a lot of radon, you're breathing those atoms in. Now they're inside your lungs. And at any moment, one of those atoms can continue its decay and fire off that alpha particle. That particle travels a microscopic distance and just slams into the DNA of a nearby lung cell. Now, one hit, your body can probably repair that. But if this happens over and over for years and years, the damage adds up. And those mutations can eventually lead to the uncontrolled cell growth that we all know as cancer. So the big takeaway here is pretty profound when you think about it. We're not talking about industrial pollution or some man-made chemical. We're talking about the basic physics of our planet, a fundamental process of geology and atomic decay, one that's happening everywhere all the time, creates a very real risk that we just need to be aware of. And that really leaves us with one last, very personal thought. This invisible intruder, it's a part of our world. So it's not a question of if it's present where you are, but a question of how much. And finding out the answer to that question for your own home, well, that's the first and most important step you can take.